Hello everyone. So welcome to the last video of the video series. Now this ends our the prerequisites and the Python basics and modules tutorial before going on to the advanced workshops. Now I hope you got the idea. And finally, we are going to discuss about the Opencv library, a very important library, a module that we can use for the best Opencv, the best image processing library available for Python and the best open source library available. And we are going to discuss about the basics of Opencv and we will do some examples as well. Now, before going on to anything, we have to understand what the image is in computers, right? So you know that image in a computer, right? So this kind of a thing. Now, this is a very low resolution image available here. But the computer that we are going to see some colors in the image, right? So in images, you know that the smallest elements are pixels, right? So there are pixels and each pixel contains a independent color and a unique color to each other, right? And that color, we are going to get a feedback and we get to know these colors and we have some idea in our mind. We can read colors, but actually what computer sees, it sees a set of numbers, right? So in other words, we can say a computer, when computer sees an image, it sees this kind of a two-dimensional array with some numbers, right? So computer sees an image as a two-dimensional array, simply, right? So other thing is, when it comes to images, we have three main types. So don't get the idea wrong. Now we have some other image types as well, but I'm talking about the major image types. So when it comes to major image types, we have three. The first one is the color images. Second one is the grayscale images, not black and white. So these are grayscale images. And third one is black and white images. So you can see the difference: color, grayscale, and black and white images. So the middle one is not black and white, it's gray, right? So how we are going to do this categorization, you have to go into a individual pixel, and depending on the value available in an individual pixel, we are going to do this categorization, right? So when it comes to a pixel, right, so you can identify pixel using the row number and the column number, right? So here what you can see is, okay, so if you want to name this or if you want to access this pixel, it has a row number 0 and a column number 0, column number 2, right? So it is actually known as image 02, 0 row, second column, right? So if you take that column, if you take that pixel, and in color images, what happens, a single pixel has three components and they are called BGR. Usually we call RGB, but in Opencv that the order is BGR. So BGR components, and these BGR components are represented by three 8-bit numbers. So when it comes to a color image in a computer, right, a single pixel has three 8-bit numbers and they are corresponding to BGR components of your pixel, a single pixel, right? So in that one, these are some sample values. So you know the 8-bit numbers, right? 8-bit numbers, you know that the range is from 0 to 255, right? 255. So the 8-bit number, the range changes from 0 to 255. So if you have 25500, that means we have pure blue, 0 from G and 0 from R. So that's the pure blue color. So if you have 0255, that means that's simply the green color, right? And if you have like 0255, that means combination of red and green, so that's yellow. And you have intermediate color like this, okay, B180, G120, and R60. So this is the color you are going to get, like a brown color, right? Then the other thing is that the black images, how we are going to draw black images, is simply black pixel 0, 0, 0, and white pixel the empty color, right? So white pixel fully from BGR component. So if you can mix pure blue, pure green, and pure red, theoretically it says that's the white color, right? So that when there's a color image, so each pixel has three components BGR, right? And also when it comes to gray images, what you have is simply you have one 8-bit number, and that 8-bit number changes from 0 to 255. So if your image is a gray image, a single pixel contains a 8-bit number, and if that pixel is like 0, that means black, and if that pixel is 255, that means white. Anything in between, it will be a gray color. So when it's closer to 255, it's a light gray, and if it is closer to 0, that means it's a dark gray, right? And in the other hand, the last type, if you have a binary image, so that simply means you have only two values, black, either white, right? So 0 represents black and 1 represent white. So you can see the black and white image is there. So black and white contains only black and white images. So like it's wrong if you refer the televisions like black and white images. No, black and white televisions, no, they are not black and white. They are grayscale televisions, right? The earlier televisions in 1980s, 1970s, right? Anyway, so now we are going to go on to, now with this knowledge, we are going to move on to the basics of Opencv, and we will first see how we can load the image to our Python code, right? In order to do that, what you have to just do now, I will show you my working location. I have a folder, so you will get these materials, and from the link of the first tutorial, there's a link is provided, so you can get the materials from there. And yeah, so in my location, this is my location, and there is a folder called, now this is my code, right? This is my code that I'm currently working, and here I have a folder called sample. So in this samples folder, we have a set of I have a set of videos and all, as well as some sample images, right? So these are there. So what I'm going to do now, I'm going to load this flower.jpg into my code, right? So when it comes to here, your code is this one. Now I'm going to go inside the samples folder and get the flower.jpg loaded into my code, right? So let's see how you can do that. First, you have to import the Opencv module, and it's not loaded like import Opencv. The module name is cv2, so you can load it using import cv2. And this is actually, let me comment this out, and this is actually how we are going to load it into a computer, cv2.imread. So the imread function of Opencv library, we are going to call that library, and we load the flower image from the samples folder. Now you have to go inside the samples folder relatively to this location that you are currently are, and then you have to load the flower, right? So flower.jpg. So this is how we are going to give the relative path. If not, what you can do is simply you can load it using the absolute path. So how we are going to get the absolute path? Very simple. I mean, you can go to the location where your image is saved. Now, okay, this is the image, and let me get the path from here, and you have to just copy it here, and then slash flower.jpg, right? So both works fine. But if you are going to give absolute path, make sure that you are going to add R like this. So otherwise, there is some kind of this, the slash issue is coming, right? So the slash, otherwise you have to, if you are not going to have this R, you have to convert this manually to other side, right? So that is bit right hard. So we will put R here, so it loads the image, right? So what we are going to do then, we get the image loaded here, and we show the image using cv.imshow. So this is the window name. So what happens, there will be a newly opened window, and in that window, this image is showed, and this is the Windows title. And here what we are going to do, we are going to wait for like 0. I will explain the cv.wait key separately, but simply what this does here is simply waits infinite time, right? So it waits forever. So it shows the window and waits forever, and until a key is pressed. So once a key is pressed, all the windows will be destroyed. Destroy in the sense like the windows opened by Opencv will be destroyed. So let me run this and show you the output, right? So you can see now the live, right? So what do you mean by live? Live is the window name, and this is the window created. Now this is open forever, right? But if you press any kind of a key, right, this code will be executed and all the windows will be destroyed. I mean the windows in the sense the windows opened by the Opencv. So wait key 0 simply waits for infinite many time. I will explain the wait key in a bit, right, totally, but for now just uh, assume that it's waits, open the window and waits for infinite time, and once a key is pressed, I mean this actually waits infinite time until the key is pressed. When the key is pressed, all the windows will be destroyed. So that's what happens. And now I want to show you something, right? Image 100 100. So what we will do here is simply uh, we are trying now. Can you remember? So you know that each pixel has an individual value, right? Image 0 to likewise. I'm trying to access the 100 by 100 pixel of the image, right? 100 by 100 pixel of the image, right? So that's what I'm trying to do here. So if you print it, right, you're going to see something like this, right? So this is the value. Now what it means, B, G and R. So this is a color image, so it has a single pixel. Now 100 by 100 pixel has three values, B, G, R. So you know it's obvious, since this is a red pixel, so the R component is the maximum and you have a reddish color here, right? And I'll do something like this now. I just printed and saw the value. So let me do something like this now. I'm going to get this and do something like this. 255, 255, 255. So what happens here, right? So if you run this, you can see the 100 and 100 pixel somewhere here has become white. So if you carefully look at this, somewhere around here, you can see a white pixel. So the pixel is changed to white. So now you know that this is an array. So you can confirm it. Image is loaded to an array. And the most important thing, these images are loaded into Python code as Numpy arrays, right? So you can get it confirmed, print image.shape. So can you remember something that we done in Numpy called shape? So this gives the dimensions, right? The row numbers and column numbers, right? So let's see what it gives. It gives like 361, 483. So this simply means it has like the resolution of the image, 361 rows and 480 rows, and 3 is simply, it says each pixel has 3 components like BGR. But this 361 and 480, so it's the resolution simply. So if we go to the original, so if you go to the original, I mean the file, and if you go to the properties and if you go to the details, you will find the resolution, right? So 480 into 360 here, right? Understood? Okay, so now quickly, let me get the original one, right? So you can confirm it. Images in Opencv are loaded into Numpy array. So that's why I told you earlier, Numpy is used everywhere in other modules as well. So Numpy is a very useful thing that we can use, right? Okay, so what it means then, if when we can confirm it is a Numpy array, we can do this kind of slicing things, right? All rows, 100 column. I'm going to make it white. So let's see, right? So very interesting, right? And okay, first two rows and the 100 column actually makes no sense, right? Yeah, so we'll do something like this, 105, and let me convert it to not so yellow color, right? So you can convert it to yellow color like this. Okay, so the other thing, yeah, so we have done the same thing, and you can save these things into physical files, right? Into physical files uh, uh, using this imwrite, right? So let me write the imwrite command. So this is the path. So in the where your code is located, this will save this image as flower. Like let's say, okay, new PNG. So I'm going to save the image. So this is the file name, and this is the Numpy array or the image object to be saved, right? So if you run this, uh, let me show you the location, right? So this is my where is my code? Yeah, this is where my code is located. So you can see the flower new image, right? So you can save the images back. Okay, so quickly now we will move on to the next topic, how to load the video file into our Python code, right? So the command that we are going to use to load the video source, not a video file, but a video source into our code is cvd.video capture. And then you have to provide the path. Now we have several options here. The video source can be a webcam, it can be a USB camera, it can be a